Welcome to the Philip Wiley Show. Take a look behind the curtain of professional hacking and hear compelling discussions with guests from diverse backgrounds who share a common curiosity and passion for challenges and their job. And now, here's your host, offensive security professional, educator, mentor, and author, Philip Wiley.
Hello and welcome to another episode of the Philip Wiley Show. I'm excited to have Jeswin joining again today. This is a continuation of the Be Fearless online series sponsored by SquareX. And today we have Jeswin on discussing more in-browser malicious file detection. So welcome to the show, Jeswin.
Thank you so much for having me. And today we'll take a look at some more interesting file detection techniques and how attackers are going ahead and evading antivirus solutions.
Yeah, sounds exciting.
So in the previous session, we had seen, how we can simply rename a file and a lot of detection mechanisms are evaded. We also covered VBA stomping as well as VBA purging. So to provide a quick overview about both of these techniques, basically inside a macro-enabled file, we have the performance cache, we have the compressed source code. And the compressed source code, as the name suggests, it's not a direct source code. So we can't go ahead and read it directly. We have to decompress it. There are containers and all of those things. So in case of VBA stomping, what used to happen was the compressed source code was kept as a genuine one. And the performance cache is where we'd have the malicious macro file. And a lot of times the antivirus solution will just take a look at the performance cache, or they'll just take a look at the compressed source code. They'll figure out that it is not malicious and they'll let it through. So at this time, the performance cache played into the advantage of the attacker, and Office will first take a look at the performance cache. The restriction with performance cache was the version had to exactly match. So the bar of exploitation was a little high because now as an attacker, you need to know which Office version the client will be using and then create the performance cache accordingly. So with VBA stomping, again, it was genuine source code and malicious performance cache. In case of VBA purging, the attack slightly changed, and this is where the AV solution, who were taking a look at performance cache, were fooled. At the end of the day, the AV solutions are processing, millions of files, if not billions of files, almost every day, and they are optimized for scanning purposes. So at times, it doesn't make sense for them to take a look at both of the things. Ideally, they should. But for optimization, they'll be only taking a look at the performance cache. So at such times, what will end up happening is if there is no performance cache, then the file is completely evading the antivirus solution and going through with it. And this is where, again, the malicious code will be in the compressed source code. The attacker will remove the performance cache. And anytime Office goes ahead, opens the file, it will end up reconstructing the performance cache from the malicious source code. So if we go back, just a second, let me go back to my browser. So to demonstrate this, let's go to VirusTotal. So I do have a malicious file, and this is the one. So as you can see, it is having like 15 hits on VirusTotal out of 60. And what we did was we simply generated a clean version of this by leveraging the VBA purging technique. And now if we upload this, it says 0. So we're able to reduce all of the flags to 0 with this. Now similarly, if we try to upload the file on Google, this will prompt as virus detected, or it should. Take a few seconds. Google is taking longer than expected in this case. And here you can notice it says attachment failed. There was some error, but usually it says virus detected. But if we go ahead, upload the clean file, it should go through. So with the VBA purging technique, we are able to evade quite a lot of detections. And that's how powerful, again, the VBA purging technique is. And it had a massive impact around the globe when it was rolled out, attackers were using it, and so on. Now, next we're going to take a look at tampering with metadata of the file. So these two techniques are specific to macros, but the other two techniques are generally applied to files, especially zip files, where we have a lot of files within it, and changing of some of these files can simply change the hash of the file. And a lot of time the hash-based checks will completely get bypassed due to this. So now let's quickly jump back to the demo. So what I'll do is I'll download a sample from Malware Bazaar. So I'll pick up a document one. Second, let me go ahead and download this. Quickly extract the file. So now we have a document file here, and what I've also done is I have also started a simple Python HTTP server here so that my whole download directory can be served right here. So if I try to download this file, this is the one that we recently downloaded. It says, okay, insecure download detected. If I try to keep it, it says dangerous download blocked. So Chrome has a service called safe browsing, and anytime we try to download any malicious file, if it's a known malicious file, it will go ahead and flag it. So behind the scenes, Chrome is making API calls. It also has a local database of hashes. So anytime a flag is filed based on the hash check, then it will go ahead and prompt us or won't allow us to, download the file, open it, and so on. Now let's take a look at how we can bypass the safe browsing check. Let me go back to terminal. So this is a file that we have. So what I'll do is I'll simply rename this file first of all. I'll rename it as, well, just a second. Let's first take a look at the type of the file. So it's a Microsoft Word 2007. So technically the extension should be docm. So what I'll do is I'll simply rename the file to maldoc.docm. So now what we'll do is we'll quickly extract this file, and I'll create it in a directory called maldoc. So now file structure will look something like this. So all of the newer version of Office files, by newer version I mean the 2007 and later ones, because they are in Office OpenXML format, which is nothing but a zip archive of various XML files, binary files, and whatnot. So usually the macro file is the VBA project.bin file. It can have a different name. The attackers can change it as needed. All of this is present in the content type.xml as well as relationship file. So to provide more insights on this, let me go back here. So this is the directory that I downloaded or extracted. We'll just quickly format the document. So here we have references to various entities. So here we have, what type of file it is. All of this is mentioned here. Similarly, there's a presence of VBA project that's also mentioned here. Where exactly it points to the relationship, or basically which VBA project.bin file it is present in the rels directory. Unfortunately, it's not visible here. Okay. Actually, it's present inside this one. Yeah. So this is a file which dictates, which VBA project.bin file it is. So technically, an attacker can go ahead, have a different VBA project.bin file with a different name. It's just that they need to add the relationship accordingly. Now, one or a couple of other few files that we have are present in the docprops file. So this is the place where we have the metadata about who created it and so on. So what I'll do is I'll simply modify this information by, let's say, John. So in a way, I'm tampering with a component of a file that more or less is not going to affect the functionality of the file. It is just a bare metadata information. So what I'll do is I'll quickly save this file and I'll package this. Currently, I'm in the malware directory. So I'll go ahead and create an archive, which is maldoc new.docm. I'll simply move this file to the root directory. And now here we have the mal.new. So just to reiterate, what we did was we simply modified the metadata. Basically, who was it modified by previously? We changed it to John. And now let's go back to our directory listing again. And this is the original one. So if I try to download it, it will say dangerous file. But if I go ahead and do this, it went ahead and bypassed, right? So that's how easy it is to go ahead and simply change metadata, a minor modification within the zip file, and it generates a new file to work with. And in this case, if you go to VirusTotal and upload the same file again, so it will trigger a new scan. So whenever it's triggering a new scan, that means the file is considered different, and some element of it will change. For the same reason, the whole scanning will trigger again, and VirusTotal will provide with the new hash to work with. Yeah, so that's how easy it is to evade, at least the basic checks that happen on the browser.
So how effective is this metadata modification technique?
The metadata modification would be beneficial for attackers, especially if the user is not having additional level of protection, right? So endpoint security solutions, your Windows Defender, as well as any enterprise grade security should be able to pick up all of these techniques, because at the end of the day, they would be scanning the whole file, taking a look at, VBA project.bin file. They're just not relying on the hash because they know that it's so easy to change at times. But if you're relying just on your browser, so for example, right now I do not have any additional solutions installed. A lot of users might not have it installed, and it could pose a risk as well. So you have to be extremely careful when you're dealing with files. You can't just rely on the Chrome's safe browsing, because at the end of the day, it is optimized for making sure the user experience is seamless, and at times they'll only be performing a hash-based check, and they won't be analyzing the full file as it's being dropped. So next, what we're going to do is we are going to move to another class of attacks, which is basically large files, and this is out there quite a lot. So in recent times, all of the APTs are leveraging this. What they'll do is they'll have a big file, and when the file is being dropped, what ends up happening is the antivirus solution might not scan it because it's way too big. And if the antivirus solution goes ahead and tries to scan it, it will slow down the whole PC. So a lot of time, garbage might be packed in front of the file to evade a lot of these techniques. And at times, it could be just genuine content placed inside the file to evade a lot of antivirus solutions. And this is quite effective in nature, and it goes ahead, bypasses a lot of AVs. So let me go and jump into another demo for this. Just a second. So here I have a couple of in-house XLSM files. So all of these files appear to be pretty small. We have 1 MB, 2 MB, 3 MB files, but we'll see how big these files can get, right? So let me go ahead and quickly upload this file, at least some of it, to Google just to showcase. So it will take a while, that's why I'll upload it beforehand. Just a second. So let me go ahead, pick 17.9 MB. So Google and all of the mail providers, based on the RFC, the emails are supposed to be within 30 MB. The data should not exceed 30 MB. And that's why, again, Google enforces a hard limit of 25 MB. And in case if the file exceeds the size, then it goes to a Google Drive link. At times, what happens is zip is a very, very dangerous format, because zip can do a lot of compression and the file could be much, much larger. So this will be one such example. So let me go back to my command prompt. So I'll go into my in-house XLSM, and these were the couple of files that we generated in-house to have a very big VBA project.bin file packaged inside a small XLSM. So what I'll do is I'll quickly unzip the file and into this directory. Let's quickly take a look at the size. So here it is 35 MB, which is pretty big. It appears to be 1 MB file. So just to show here, it's a 1 MB file, but behind the scenes, the VBA project.bin file is 35 MB. So a lot of times antivirus solutions won't go ahead and perform as rigorous check because they'll notice, the file is relatively large, and this applies to the mail providers. VirusTotal should be capable of scanning this. Let me go ahead and extract a couple of them. So let's take a look at the 6.xlsm. If I change this to 6, so the 6 one is 675 MB, right? So, and this is the file that's there. It's 28.2 MB one. Now, if we go ahead and do the same for 8, the extraction is taking a while. So this is a very, very big one. And this comes out to be 1.8 gigs. So that's a crazy compression that's happening with the help of zip. So this is the file, a 33 MB file decompresses to 1.8 gig file. Now,
wow, that's some serious compression.
Yeah. Now, the moment we try to upload this on VirusTotal, right? So let me go ahead and do this. First, what I'll do is I'll quickly upload the smaller one, which is just having 33 MB of VBA project.bin file. Uploaded. Let me duplicate this. I'll upload the bigger one, which is 33 MB one. So this is 1.9 gig one. So good thing is the small file, the 33 MB one, was being processed, and now the bigger one, I had already scanned. But what will end up happening is if we try to reanalyze this, it will take a long time. It will take a long time. Let me go ahead, open VirusTotal. Now, VirusTotal says that when you're uploading the file, right, the max size is 650 MB. So we know for sure that this file is definitely going to evade it because the VBA project.bin file itself is around 1.8 gigs, which is a massive, massive file. And all of this, when we are uploading to Google, it won't prompt because Google behind the scenes is also, performing some limitation on the amount of data it's going to scan. And as a result, again, this file went through, it will be delivered on your inbox as well. It won't create any problem as such. And that's how, again, attackers are leveraging this. They're just packaging the file content with, genuine data at times and then placing the malicious content at some place else. So if we try to open the same file, so I have a VM with me. So let me go ahead and open this file. So this is the same 1.xlsm. So this is a 33 MB file. I click here, it should trigger. And there we go. So this will go ahead, trigger the same malicious macro. And if I show you the macro, actually, this is the macro. I'm not sure if I'll be able to open it up. Let me go ahead, close this first. Okay. So this is a macro, right? So what we are doing is we are having multiple sheet. One sheet is triggering the malicious payload. At the same time, the other sheet is just having simple message box, and message box is considered a very genuine, normally used macro. It's not considered malicious. And all we are doing is having 100,000 lines of these message boxes just to bloat the file sufficient enough so that all of the antivirus solution will go through with it and they'll won't be able to scan it because of the size limitation. And this is how we are able to get up to 1.8 gigs. All there is just this repeated content, and there are like 100 such sheets, and this amounts to making the VBA project bin bloat quite a lot. And at the end of the day, we can have the malicious payload right there in the last sheet, and the antivirus solution will just won't look through with it because of the size limitation. So it, I think, took around 1.5 minute, and most of the solution out there, right? So they remain undetected. Some of them did not say anything, But the big solution out there, so here we can notice it's timing out, right? Because the sandbox where all of this operation is being performed will be limited by memory as well. And now to load the file first in memory and then trigger it grows further quite a lot into memory, and it can effectively crash the sandbox as well at times if the sandbox is not big enough. And as a result, again, the antivirus solution might not be able to identify malicious files which are large in size.
So is there any way that antivirus solutions can combat these type of attacks?
I think it's a cat and mouse game. So what the antivirus solution can do is, one easy way could be to, while we're performing static analysis, we can do it in chunks, and that's something we'll be doing with SquareX as well. So with SquareX's in browser analysis right now, at least from the public version, the limit was 6 MB of document files that we're scanning, because if any file, especially if they have a VBA project.bin file that's greater than 6 MB, it's a red flag. Usually the files are much, much smaller in nature. And right now we are, with the newer version, we are going to increase the limit up to like 450 MB. At the time, again, it will take a while, but it will be able to perform the scan. Later on, what we'll have to do is eventually, take chunks of file, process it accordingly. So streaming is one way to deal with, large size files, but that will only be beneficial in terms of static analysis. In case of dynamic analysis, at the end of the day, it depends on the sandbox. So various AV solutions, in case if they are not able to detect that nothing has been found, one easy way is to simply bump up the size of the sandbox to see how the file will behave. But definitely it has to be done, otherwise a lot of threat out there will end up compromising end users. So along with, and I hope the bigger players, the enterprise endpoint solutions, paid products, all of those are going ahead and doing this. They have this very aggressive scans on malicious files. So now let's take a look at how SquareX's detection is going to help us. So right now here I have both the malicious file as well as the large file in the in-house XLSM. So what I'll do is I'll quickly enable our download interceptor feature. So to provide more context about how download interceptor work is, anytime you download a file, it could be anywhere on the web, it could be from Outlook, Google Drive, whatnot. Our download interceptor feature will provide you an option to open it in disposable file viewer. So just to provide some more idea, let me go ahead and start it up. So if I try to download this file, what will happen is here I have a prompt that says you can open the file and save file viewer, and if you click on it, the file automatically gets uploaded to our disposable file viewing environment. Take a few seconds. Yeah. Okay. For some reason, the file did not upload. Yeah. But in this case, what we have done is we have introduced scanning facility for our download interceptor. So anytime you download a file, for previously we were just relying on or like having the integration with Gmail. So Gmail will anytime go ahead, you get a malicious document, it will go ahead and show you not scanned, malicious document, save file and whatnot. But the same capability has been extended to our download interceptor feature. So all we have to do is go into the file viewer one and enable these two options, and these will be rolled out in our upcoming version. They're not available in the public version yet. So the moment I enable this, what I'll do is I'll quickly go ahead, reload the page, and I'll try to download the same file again. And here you can notice we immediately performed a scan on the file as soon as it dropped from the browser. We click on this, and now you have the similar option that you have seen previously. Here we have a full-blown technical analysis that, it has the auto-open keyword and a couple of other what we consider malicious function calls, which are very, very dangerous to have. And the metadata modifier, all of this information is available. There's option to clean up the file. So you can perform the cleanup, and it will perform the cleanup right there in the browser. And here we can notice the file is now a clean file that's being generated. Similarly, if I go ahead, open this one, this is the file that I had modified with the metadata one. Good thing is that we are taking a look at a lot of things apart from, metadata. So metadata, even though it says John, our analysis still runs, and the whole metadata modification won't be as effective with SquareX at least. And now let's take a look at the large files. So in case of large files, let me start with the 1.xlsm. So this is the one that's having 33 MB. It will take a few seconds, and it was able to flag it right there. So VirusTotal took a long time, and it was able only 2 scanners were able to detect. Rest of the big scanners we are talking about, Google, Fortinet, Malwarebytes, Microsoft, all of them went undetected. But in our case, it went ahead and flagged it. Similarly, if I do it for a slightly larger file, I think this is having a VBA project.bin of around 60, 70 MB. So all of this analysis is happening right there in the browser, and it goes ahead, flags it as well. So it can go up to like 400 MB, and this is the one that's crashing on VirusTotal. 1.8 gigs is too big for us right now because, again, at the end of the day, browser has some restriction on how much data we can be having on the extension side. So 1.8 gig is too big, but slowly we'll bump up the support as we are moving forward, and we know that we can have the limit increase to 0.1. And now another big feature with our download interceptor is that it works across every download now. So anytime you go ahead, let's say you're downloading a file from Outlook, we don't have a mail integration with Outlook yet. The team is working on it. But let's say you download a file from here, it will be picked up automatically by our download interceptor, and it will go ahead and perform the technical analysis and provide the insights to you. So with the download interceptor, it's a big win for all of the files out there, whether the file is coming from Google Drive, whether it is Telegram, WhatsApp web, whatnot. It's a overall full-blown file analysis that we'll be doing on all of the downloaded files. Yeah. Let me go back to slides. So these are the features with our download interceptor, file scanning, WhatsApp, Telegram web, all of these platform works, Outlook, Proton, Mail, Google Drive integration works. And in fact, anywhere from where the file can be downloaded will trigger our download interceptor, and the scanning will work. The current limitation is around 450 MB. We'll work on extending it further. So 450 MB right now is a big size compared to what existing EV solutions are offering right now. And please note, all of this scanning is happening right there in the browser. So it's very, very fast compared to the existing solutions as well.
Yeah, it's very, very interesting. Good to see the continued evolution of SquareX. So I appreciate you taking the time to share that today, and I look forward to some of the future features of SquareX.
Yeah, we'll be adding a lot more detection on the malicious file side, because that's one attack vector that attackers are leveraging quite a lot. So recently I was reading about how, with HTML smuggling, people are able to write a disk file. And then what will end up happening is it's a disk file, right? So if people accidentally click on it or intentionally click on it, it will mount it as a disk on your Windows operating system. And this way they are able to evade mark of the web, which basically indicates whether the file is downloaded from online, any internet website, and so on. So disk image could be another format to add as well. So we'll be adding a lot of different file type support in the future. Office file was one of the most popular attack vector out there. It's like very, very commonly used. So soon we'll be extending it further as well.
Yeah, something that's been around for a long time too.
yeah, it's been like 2 decades since these vectors have been there.
Yeah, very interesting. So thanks again for joining and sharing the new features.
Thank you so much, Philip. It was great to be back on the show, and we'll see you next.
Yeah, great chatting with you as usual. So thanks everyone, and thanks for joining, and we'll see you next episode. Make sure to go to SquareX and start using SquareX to help protect you. I mean, this is a nice product and it's free for users. I've been using it myself and I'm really enjoying it. So if you look in the show notes, we can show you how to easily find it.
Thank you for listening to The Philip Wiley Show. Make sure you subscribe so you don't miss any future episodes. In the meantime, to learn more about Philip, go to thehackermaker.com. and connect with him on LinkedIn and Twitter at Philip Wiley. Until next time.